Hi, welcome back to Fall CS 170. Wanted to just share a couple of things just to answer a couple of common questions that we're getting and just to make sure that people are getting the help that they need for some of these questions. So I think one question that came up quite often is like there's like a lot of links on here to look at. What are the main things to look at to understand what you have to do for the class. So I think one thing to make sure everybody knows is you see here under announcements, make sure you are paying attention to those announcements. I know that a lot of people might have been transferring around in different sections, so they may not have seen some of the announcements. And now for me, you see a lot of these announcements. That's because I have access to all of the announcements. Hopefully, what you see should be a lot less announcements, and it should be focused on the sections that are under my coverage. So you should see a lot less of these. But just in case, you still see a lot of different things, I'll try to make sure that the important things are available through the other channels. So one of them to look at is modules. All right, see under the modules, you'll see all kinds of stuff here. You'll see your syllabus. You'll see your recitation locations, which is for us is basically going to be your professor or your TA's WebEx location. You'll have the student schedule. See if you see the student schedule. Um, you'll see this. And you'll see week by week all of the different topics that we're covering, the chapters that we're covering, what the recitations are going to be covering, the assignments, post date, due date, so on and so forth. And you'll see the different color shading, which breaks the course up into 3 different sections, really for your first exam, second exam, and for your final, right? So I think this lays it out pretty clearly. You'll see all the quizzes and whatnot. So it's like a lot of information that you should be able to get off of that Excel sheet. Now the other thing you can look at, you see all these resources here, right? So we have the week 1 resource, the week 2 resource. I think I highlighted that in previous lectures. So you can see all of this, right? Whether it's the textbook, the lectures, the learning objectives, various resources to do the conversions, vocabulary, so on and so forth. So pay attention to that. Now in terms of the videos, I know you guys might have missed some of those announcements, so you might want to go to here where it says Media Gallery. And I think I'm the only one that's really posting in here, so that's why you see all of these are basically from me. So you can go into the detail view here, and you can still see it sorted by creation date. Okay, so at the bottom down here, I kind of uploaded these kind of at the same time, but you can see everything from the intro lectures all the way up to week 2, and I'll be adding more to this. So if you ever lose track of the videos, I know I'm posting them up in like small clips, so you should be able to see all of that going through here. Now the other thing I've done, in case you need more help with this, just remember under Files, you can see Resources, allow resources. And so I put each of the PowerPoints as PDFs up here. The binary conversions, Excel that I did for you before. I also have the class videos here, right? And then you have your logistics that I posted up. So here, as I add videos, I'll be posting them up to here. So if you ever lose track of it, you can always come to here. You can see the video link. And you can see a short description that I placed next to it. I kind of think it's easier just to go to the media gallery, but again, it's out there if you want to take a look. So I'll try to keep that in sync, um, but that's how you can look at all the videos that we're posting up. Now, the other thing that people are starting to use more of is Piazza. And Piazza is really more for like people to post up like group questions or questions that would be useful for the group. Um, and we'll be able to have either TAs or even other students answer some of these questions. Um, so this might be a good area for you to go to. So you'll see Piazza here. You can click on that and you'll see different categories of questions and whatnot in here. So if I go here, this was just an intro. Okay, so this is not really at us. You can see the question and it's at section 11. Okay, so section 11 is not for you. That's not the asynchronous. So that's why they're asking about this recording. So the professor who's going to cover section 11 will answer this. You guys probably don't see much on your side because you haven't really been using much of Piazza, but as we go along, some of the work assignments, there'll probably be a lot of questions that you might want to put up here, and this is a good place to get not only just an instructor to answer, it could be TA, it could be other students to answer questions. Okay, so just keep that in mind. Okay, so here you see the video. I'll close this up and let's go over to here. So the other questions that I got was a lot of questions around the conversions. Okay, so you remember last week I was kind of mostly talking about the base 2 conversions, and I kind of set up this Excel spreadsheet, and you can remember I kind of laid it out in kind of a detail, not only really just to teach people on the video, but also to lay it out because when we do these conversions, you have to show the work for it. So I was just actually talking to Professor Trees about it this morning, about what does it mean to show the work on this. So, we're basically almost like writing a program on how to do the conversion here by putting all the logic here in Excel. So I think you want to be able to show like you understand the logic. It's not just you copied a program and made it work to show the conversion. So here you see all the base 2s. Here you see all of the exponents. And here you see the calculated value, right, which is basically taking this exponent to that, right, and that creates these numbers up here. Okay, and you remember from the lecture, I just took this sample number here, right, but just as easy, I can just change this, right, so I can make this 0, let's say, and you can see my number over here changed to 103 as the decimal. Okay, well, let me put this back to here. So I've essentially wrote like a little program, you can say, to do conversion of a binary number to a decimal number. Let me make this bold here. Okay, but I think when if you actually want to do something like this on the exam, you need to kind of show this, right? So you might be able to say, okay, I built up this base times exponent table, which lists all of the exponents for a base 2. And then I took all of these to calculate this, right? And then you can see I made a comment here. I said convert it to decimal using its sum, right? Which is this, right? So somehow you want to be able to, if you're going to do something like this and you want to show this as work, you want to kind of be able to talk your way through it. You could describe it in a paragraph here, or whatever, just so that people know you didn't just copy and paste the formula to calculate this. Okay. Another thing I want to try to do, I didn't really go much into hex. I kind of went through it fairly quickly. There's a number of ways to do these conversions. I'm just showing you a little bit of the way I think about it, and I kind of implement it into a spreadsheet so you can kind of follow the formulas. Okay. So one way to do it is really just to see I have base 2 here, look at the base 16, and basically do something similar, right? So now instead of the base being 2, I made it 16, right? And then the exponents are the same. And the calculation based to the exponent is also the same, right? So everything's all the same. I just copied it over, right? So I follow the same logic. Basically, all the calculations, the same thing here. I would sum it up, okay? So that's a very common thing that you might be looking to do. So, let's say I wanted to take 231. Here's the 231. And I wanted to convert that. So I would do, let's say, equals. And I would take the 231. And I kind of went ahead a little bit, actually. So you can see this 231 is less than 256, right? So it's not going to work. I have to go to this one, 16. So 231 is bigger than 16. So I take the 231, which is this K9 cell, and I divide it by this 16 here. Okay, so this cell is 14. So 231 divided by 16 is 14 point something, right? You can see 14.4375 here, right? I just round to 14, right? And then I want the remainder of this. So that's where we had the mod function. That's where I forgot the mod function last lecture. But here's the mod, and then I'm going to do the same thing. So I'm going to take the 231, comma, 16. Okay, and that gives you 7, right? And what you do as a generalized calculation is you take this 7 over to here, the next place on your digits here. 7 divided by 1 would be 7. Okay, and your remainder would be 0. Okay, you might see this in textbooks or other little snippets, documentation to do conversion by remainder, and this is what they mean by that, doing by remainder. So you do the division, you get the number that you get out from that, and then the remainder is at the bottom of that, and then you carry that over to the next column. So you end up with this. Okay, so if I move over here to the right, you can see what I did is I lined up all these binary here and a hex here. So this is binary here, and then this is hex, and this is decimal, right? So the reason why I did that is you have 14 here. See 14? 14, that lines up the hex of E. So that's an E right here. And then you can see the next character is 7. So 7 is 7. Okay, 7 to 7, decimal to hex 7, and you get an E7. Okay, so that's one way to convert that 231 into hex. Now the other way you can do this, and this is why I listed these binaries. Okay, and in case you don't really see it or you don't know, I basically just taking a binary and incrementing all the way up to cover the 16 characters that you have under hex, right? So hex, you go 0 to 9, A through F, that's 16 characters. So you start off with 0, right? That's easy. So the first digit is 1, right? So that becomes 1. This is 2, so on and so forth, right? So I'm just basically incrementing all of the binaries up to 16. So even if I gave you a blank sheet of paper and told you to come up with 16 characters to line up with the hex, that should be easy, right? So you should be able to go like this and just keep on adding 1 all the time until you fill out this table like this. Okay. Now the reason why I did this is because another common way, which is pretty simple. It may not really tell people that you understand really how to convert binary to hex, but it will get the job done. Is to set up this table like this and break up the binary into chunks of 4. Okay, and if you don't have enough for 4, you put leading zeros in. So in this case, you can see 1, 1, 1, 0. Okay, so what does 1, 1, 0 mean? You have 1, 1, 1, oops, 1, 0, which equals to E, right? And that's how come I end up with E here. Now let me look at the next 4 digits. 1, 2, 3, 4. That's 0, 1, 1, 1, right? So where's my 0, 1, 1, 1? It's right here, and that equals to 7. So you get E7. So, and I kind of showed that in the PowerPoint in one of the lectures too, where you basically group the binaries into sections of 4, right? And you take each of those 4, you look up the mapping here, and then you get your hex, and then you draw it out like so. So that's another way to do it. I have to say that you can probably do this without really understanding the mechanics of doing a binary to hex conversion. So just be a little bit careful with this. This is a quick way to do it. You can show this. You can say, well, I know how to do all these binary, and I grouped it in sets of 4, and I mapped it to hex, and that's how I came up with this. So you just have to show that you have some sort of algorithm or process to do this conversion. Okay. Now, if you do it this way, like on the left-hand side, where you show the exponents and then you're dividing and doing the mods, that probably shows that you understand a little bit more of what it means to translate from one to the other, right? So just like you saw how I took this base 2 and took all this out here, I applied the same algorithm, and I just changed the base to be 16 when I did the hex. And I know some people asked about the base 8. Really, there's nothing different, right? So I could have done the base 8 with the same thing. So I go like this. Oops. Right? All this is the same. And then the base is just 8. Now let me just drag this over. That's base 8. And then I'm just going to copy this over. And you got the same thing, right? So you got, 8 to the 0, which is 1, 8 to the 1, which is 8, 8 cubed, and so on and so forth, all the way through. And if I want to do the same conversion to base 8, I'm doing the same exact thing, right? So I'm taking this 231, and I'm going to divide it by 64, because you can see this 512 is bigger than 231. Right, so 231 divided by this, take the mod, and carry it all the way over, and then you'll get your base 8 number. Right, so you can see if you do it like this, this is a very general form of doing it that you can apply to whatever base you want. Okay, like I said, I think people might refer to this as like conversion using the remainders algorithm. But there's a number of ways to do this. This is one way I suggest. It's pretty easy to implement this type of logic like I just did in an Excel spreadsheet. Okay. If there's any questions, feel free to let me know. And if you want to share some other ways of making these conversions easier for you to understand or digest, feel free to let me know, and I'll work with you. But hopefully this helps you to understand conversions better. Okay, thank you.